Okay, 7.4, we're going to talk about our properties of logs. There's going to be these three properties that as long as you get these three down, then you should have no trouble with this lesson, okay? We will use these properties for 7.5, what I'll teach you next class, but for now, we're going to use this for predominantly the whole lesson in your whole worksheet, okay? So I'm going to reference back to your exponent properties, and then to show you they kind of go hand in hand. So if I had my exponents back in chapter 6, if I had x cubed times x to the 5th, I was multiplying like bases. But what did I do with my exponents? I added them to give me x to the 8th. So if I'm taking the log of two things being multiplied, I can separate those two things being multiplied by adding. Okay, so if I had log of 2x, and it could be any base, but if I have log of 2x, that means I could separate my 2 and my x by saying log of 2 plus my log of x. So we're going to have examples where we separate, and then we're going to have examples where we put these two together into one log. Okay, so when you multiply, you're going to add. Okay, so that means if I go back to my exponent properties, if I had x to the 10th over x cubed, what would I do with those exponents? Subtract them to give me x to the 7th. So whenever I'm dividing, that goes hand in hand with subtracting. So same thing with logs. If I had the log of 2 divided by x, then I could separate that and say log of 2 minus my log of x. Okay, so multiplication you add, division you subtract. To me, those are easy to know. Okay, now this power property tells me if I have the log of anything raised to an exponent, I can take this exponent, and my power property tells me I can move it to the front to become a coefficient of your log. Okay, so if I had log of x squared, okay, I could take this exponent and it comes in the front and it becomes 2 log of x. Okay, so if you get those properties down, you are good to go. Alright, so our examples. If all I tell you is to simplify, that means you're using those properties. Okay, so if I have log of square root of 3 plus log of square root of 12, this plus sign tells me I'm really doing what operation? I'm multiplying. Okay, so I'm getting it down to 1 log, but I'm multiplying the square root of 3 times the square root of 12. Okay, well, square root of 3 times square root of 12 is what? Square root of 36. And the square root of 36 is 6. We're not going to do a plus or minus because you cannot take the log of a negative number. So it's just going to be log of 6. Okay, so then in the next example, I have log of 5 minus log of 15. This minus tells me I'm going to divide. So I get 1 log, and I'm dividing 5 by 15. And then I can simplify. 5 over 15 is 1 over 3. So log of 1/3 would be my answer. I'm not getting a decimal because I'm not evaluating, I'm just simplifying. Okay? Bless you. Do we have questions over that? Alright, so if I have negative 2 log of 1/4, okay, anytime I have something in front of my log, I bring that over as its exponent. Okay, so that means it's log of 1/4 raised to the negative 2 power. Okay, what do we know about negatives? Negative exponents. It flips everything, right? So 1/4 really becomes 4, okay? And so really what I'm doing is 4 squared, which is 16. Okay, if you needed to do the work to see how I got there, all you're doing is 1 to the negative 2, 4 to the negative 2. These just flip-flop. 4 over 1 is 4, so you're just doing 4 squared, which is how I got that 16. Okay, but if you know negatives flip and you can do 4 squared in your head, then I'm okay going straight from here to here. Okay, but I have to see this and then your answer. All right. So then I have 2 log of 6 minus log of 3. So my first step is to move this 2 back to its exponent. So that's going to be log of 6 squared minus log of 3. After I do that, I can get 6 squared, and this minus tells me I am dividing. I better have a fraction, so I've got log of 6 squared, which is 36 over 3. So I can do that in one step, and then that gives me log of 12. So if you have a minus, that means you should have a fraction. Okay? We good with that? All right. So what if I tell you evaluate these logs using given information? So I tell you 2 specific logs. I tell you log of 5 is approximately 0.898 and log of 8 is approximately 1.161. Okay? So what I'm having you do is, given whatever value your problem starts with, you're going to manipulate it to get a 5 and an 8 somewhere. Then once you manipulate it to get 5 and 8, then you can substitute these values in. Okay? So some of them are straightforward like this. Log of 5 over 8. Well, there's my 5 and there's my 8, but I have to separate them. Okay? So if I have a fraction, that means I separate with what operation? Subtraction. So I've got log of 5 minus my log of 8. So log of 5 is 0.898 minus log of 8 is 1.161. And then I just calculate that. And that is a negative 0.263. Okay? So if I give you log of 40, what does 40 have to do with 5 and 8? So 5 times 8 is my 40. So then I split that. Multiplication means I'm splitting it with addition. So log of 5 plus my log of 8. And then there's my 0.898 plus my 1.161. And that gives you 2.059. Okay, so then log of 1/5. Okay, you just did 5/8 by separating your 5 and your 8. But here, if I separated 1 and 5, I don't know what log of 1 is. Okay, so I'm not going to do that. But what could I do with 1/5 to give me a 5? I can use a negative exponent, right? 1/5, if I bring that 5 up, that becomes log of 5 to the negative 1 power. So then I can take this negative 1 and move it to the front and have negative 1 log 5. So then I've got a negative 1 times my 0.898, which just gives me a negative 0.898. Okay, do you understand what I'm doing? Do we have questions? Okay. So then log of 64, how can I manipulate that? As 8 times 8, or you can say 8 squared. Either way, okay? If I did log of 8 times 8, then that's log of 8 plus log of 8. So that's my 1.161 plus 1.161. Which gives me 2.322. Or if you see 64 is 8 squared, I could do log of 8 squared, bring my 2 forward to log of 8. 2 times 1.161, it's still going to give me my 2.322. So you can see it either way. Okay, so then log of 125 is what? 5 to the third. So I bring my 3 forward. 3 log of 5. So 3 times 0.898. And I get 2.694. Y'all good with this? Okay. So if I have log of 125 over 64, we know that log of 125 is 5 cubed, and 64 is 8 squared. So then I can separate that and say, okay, I know I have an exponent. My exponents come forward, right? We all know that. My exponents come forward. Anytime I divide, I separate it with subtraction. So you could go straight to 3 log of 5 minus 2 log of 8. I'm okay if you write this first step and then go straight to that. So then 3 times 0.898 minus 2 times 1.161. And you can type that all in one step in your calculator. And that gives you 0.372. Do we have questions? Okay. Okay, so expanding is pretty much what we just did. You're separating. You're going from one log and separating everything you possibly can. Okay? So there is one rule, though, that it says log base 2 of 2 equals 1. Basically, what that rule is not just for 2. It's saying if I have any log of any base, so the base and the value right there is the same, it's always going to be equal to 1. Okay? The algebra behind it is because if I put log base b of b equal to x, so if I evaluated that, so last lesson we evaluated by setting it equal to x, and then exponential form, log base, my base is b, solution equals exponent. If I set it in exponential form, then that x is equal to 1. So anytime you have these same values right here, whether it's 1 million or 2, it's going to always equal 1. Okay? You are going to have to memorize this. Okay, so if I have log base 5 of 5x, I need to separate that 5 and that x. It's multiplied, so I'm going to say log base 5 of 5 plus log base 5 of x. You keep that base all the way through. Okay, and then log base 5 of 5 is 1 plus my log base 5 of x. And I'm not going to evaluate log base 5 of x because I'm not evaluating, I'm just expanding, and I can't do that with x. Okay, so then I've got a log of 4x over 3. So I know where there is a fraction, I need to have subtraction. Okay, so I'm going to have log of 4x minus my log of 3. But I'm not completely done because 4x is still being multiplied. So I can separate my 4x to become log of 4 plus log of x minus log of 3. Do y'all understand that? Okay. So then I've got log of base 7 with the square root of AB. Okay? Back in our exponent chapter, we had the nth root of a could be written as a to the 1 over n. Okay, so if I have the square root of a, that's a to the 1/2. If I have the fifth root of a, that's a to the 1/5. Okay, so this square root of ab can be rewritten as log base 7 of ab all raised to the 1/2. But that ab is together. Okay, so I can do one of two things. I can distribute that 1/2 to both a and b and then separate, or I can move this exponent forward. There's my 1/2, but I'm going to have to separate this a and this b. What's being multiplied, so what operation do I do? Plus. So I'm going to have log base 7 of a plus log base 7 of b. So that 1/2 is going to have to be distributed. So you have to be careful. If I'm taking the square root of more than one thing, that root has to go to both. So that exponent, that 1/2, becomes 1/2 log 7 of a plus 1/2 log 7 of b. Yes, ma'am? The square root is 1/2. The cube root would be 1/3. So whatever this root is the fraction, the denominator of that fraction. Bless you. So some of these you're going to have to be careful with distributing. Okay? Now, when I have natural log of 2 over 3x cubed, okay, I can separate my fraction natural log of 2 minus natural log of 3x cubed. But I have to be careful. I need to separate this 3x cubed. Does the cubed go for the entire thing or just the x? Just the x. I need to separate this right here. If I know I have to separate, I'm going to go ahead and put natural log of 3x cubed in parentheses because that negative in front is going to both of those terms. Okay? You're going to have to be careful with that. So this is going to be the natural log of 2 minus, in parentheses, natural log of 3 plus, go ahead and bring that 3 forward, 3 natural log of x. Then I'm going to distribute that negative, and it gives me natural log of 2 minus natural log of 3 minus 3 natural log of x. And that would be your answer. Okay? So I'm going to tell you something to pay attention to, and if you memorize this, you shouldn't make mistakes here. If you have a fraction, okay, a plus in front of it makes it go in the numerator. A minus in front of it makes it go in the denominator. So if you know this, you can check yourself when you're either expanding or condensing and make sure it's in the same spot that it should be. Okay? So this 3x cubed, the 3 should have a minus and the x term should have a minus because they're in the denominator. Okay? So if I was going in reverse, which we're about to do, we're about to condense it, I would know anything with a minus should go on the bottom. Okay? Even if I had a positive minus positive, I should know all positives go in the numerator, all negatives go in the denominator. Okay? Hopefully that might help some of y'all so you don't forget to distribute that negative. Okay? Alright. So then log of 5x cubed over y I'm going to separate log of 5x cubed minus my log of y. Now here, I know I have to separate my 5x cubed. I don't have to put this in parentheses because there's nothing in front of it. Okay, so I can just separate that to be log of 5 plus what? 3 log of x minus my log of y. Okay. I want you to try the next one. The 4th root of y is the same as y to what power? To the 1/4. So this is really the natural log of 3 plus 1/4 natural log of y. Okay, are y'all good with that? Do we have questions? Okay, now we're going to go in reverse. So when you condense it, you're trying to go from multiple logs all the way down to 1. Okay, so if I look, I have log of 9 plus 3 log 2 minus log 3. I'm going to start from my left, okay? I'm going to combine these first two, and then I'll combine that with the last one, okay? I do not want you going straight all the way down, no work to the answer. If you do that, you just won't get partial credit, okay? So I don't want you doing that. But here I've got log of 9 plus, that plus means I'm multiplying, so I'm going to have log of 9 times. The mistake I've been seeing is that some people are still putting a plus here. Remember, you are multiplying when there's a plus, okay? And then this 3 goes to the exponent, so 2 to the 3rd minus log of 3. Okay, so then I've got 2 to the 3rd, which is 8. 8 times 9 is 72. I know the minus tells me I should have a fraction. So I'm dividing 72 and 3. So 72 divided by 3 is 24. So then I've got natural log of 4 plus 3 natural log of 3 minus natural log of 12. So 3 will go with my exponent, and I'm going to multiply that. So natural log of 4 times 3 to the 3rd minus natural log of 12. So 3 to the 3rd is 27. 27 times 4, 108. And I'm going to divide that by 12. So the natural log of, what's 108 divided by 12? 9. Questions? So here I've got 2 log of x plus log of 3 minus log of 2 plus log of x. Here, it already put it in parentheses for me. So I'm going to combine these first 2 and the last 2 that are already in parentheses. Okay? So this 2 goes to the x squared. So I'm taking log of x squared times 3 minus log of what? 2x. Okay. So x squared times 3 is what? 3x squared. I'm going to have a fraction because I have a minus. And I'm going to put that over 2x. Then I'm going to see, can I simplify? I can simplify my x squared over x. So that gives me log of x squared over x just simplifies to x. So 3x over 2. Okay. So my next one, I've got 4 natural log of x minus 2. This is in parentheses. This is my entire thing together. I do not separate this. Okay? If it's in parentheses with 1 natural log, I do not separate. Okay? If I would have had natural log of x minus natural log of 2, then I would have done that. But I don't re-separate. Okay? So this 4 goes directly to the x minus 2, and then I'm going to combine what's in parentheses. So I've got natural log of x minus 2 to the 4th power minus natural log. This 3 goes to the y, so that becomes y cubed. And I'm multiplying that by 4. So that becomes 4y cubed. If you need to do that in separate steps, you can. But if you should be able to know that becomes y cubed, that means times 4, there's my 4y cubed. So then subtraction means I'm going to have a fraction. I'm going to divide x minus 2 to the 4th power over 4y cubed. And you cannot ever cancel out this 4 as the exponent with this 4 as the coefficient. Do not do that. Okay? People start doing some weird canceling with logs, some weird operations, so do not do that. Okay, do we have questions on that? Okay, so now we're going to do the change of base formula. You're going to have to know this formula. It is not hard to do or memorize. But this is saying if I have a log base c, okay, the scientific calculator will not let you type in anything other than a common log of base 10 and a natural log with base e, okay? So what we're going to do is use the change of base formula, and I'm going to take the log of a over the log of c. So I'm changing the base from c to a common log of 10, okay? Now, if I specifically tell you natural log, then you're just going to do natural log of a over natural log of c. Now you're changing it to a base of e instead of c. Okay? So if I have log base 5 of 8, my formula tells me I'm going to take the log of 8 over my log of 5. Your log of your base is always the denominator. Okay? And then I can type that in my calculator. I'm going to get my fraction. To get your log, remember you do second, and then the log is underneath the percent button. So second log of 8, second log of 5. Round it to 3 decimal places, and I get 1.292. We're good with that? Okay, so if I have log base 8 of 14, then my change of base formula is log of 14 over log of 8. So I type that in my calculator. And that is 1.269. So then if I have log base 26 of 9 and I'm going to do the change of base formula to be a natural log, then it's just going to be natural log of 9 over natural log of 26. So to get natural log, you're just going to go to the right when you're in your log screen. Just go to the right, natural log of 9, the natural log of 26. Any questions on this? Okay. So log base 12 of 30 is a natural log. I'm going to do natural log of 30 over natural log of 12. And that'll be 1.369. So you will have to know that formula. When it says change of base, you'll have to know how to do that. I will not provide you with that. Okay? Do we have any questions? Okay.